Okay, let's solve the tutorial problem in module 2. Okay, there are 8 problems here. Let's solve the one by one. The first question is creating and manipulating array. Okay, so there are many sub questions, but this one is these are the relatively simple question. Let's copy this initial random value. Okay, and save this file to the module 2 tutorial creating manipulating array. Okay, A is vector A, that is a copy from the vector 1, right? And then the third value in the vector A, third value, is a change it to the value 1. Meaning that we are going to assign the value 1 to the third location of the vector A, right? So we can write a script like this, right? Vector B is a copy from the vector 1, right? These are the assignment statement, right? And then the value of the third and the fifth element in vector V are changed to value 1. So you can write a script like a third element and fifth element. How can I write a script in the right hand side? We can write a value 1. We can match the the size of the left and right hand side, or you can just simply value 1. Okay, why? This one is these are the Scholar value assignment. If you take a look at the course material, you will see sorry, here, exception to this is a Scholar can be assigned to any size subset. Okay, so like you can only place on a single Scholar, and then this Scholar is assigned to all the element that you are referring. Okay, good. So what about the C? C is a vector. C is a copy from the vector 2. Then the value of the third and fifth element in the vector C is a vector value 2. No, this one is exactly same, right? So you can, write a script like this if your number of elements they are referring is small. Make sense? Good. What about the D? Vector D is a row vector, is a copy from the second row of the mat 1. How can you read the second row value in the mat 1? Mat 1, second row, right? And vector D is equal to mat 1, 2, comma, colon, right? So meaning that this row vector will be assigned to the vector D, right? E is D. Okay. Column vector is copied from the first column of the mat 2. Okay, vector is the column vector is copied from the first column. What is the first column? Column is entire row and first column, right? Okay, and G is the G is a matrix. Okay, first, second, and fifth columns of the matrix are 2. Okay, I concatenate in the row or horizontal direction and assign to the mat G. So you can write a script like mat2. You can read the individual column like they concatenate the row direction like this. Second, mat2. Third, right? Okay. Or you can write a script like this. 1, 2, 3. Okay. This one is basically read the in this case we don't need to bracket because we are not concatenating this column vector, right? So we are reading the 1, 2, 3 column vector. Okay. So let's comment it out, this one. And H is the mat H is equal to, that is a 10 by 6 matrix. Okay. Y is and concatenating mat 1 and vector 1. Mat 1 is the 10 by, right here. Mat 1 is a 10 by 5, right? And vector 1 is the 10 by 1. So if you concatenate this matrix and vector in a horizontal direction, that become a 10 by 6, right? So you can simply write a script as a mat 1, vec 1. Okay? Make sense? Okay, so what about the I? Mat I is the 11 by 5 matrix. Y, mat 3 is the 10 by 5. Vector 2 is the 1 by 5. Okay? If we concatenate this value in a column direction, that will be, okay, makes sense? So here in the H, problem H, 10 by, so 10 by 5, right? This one is a mat 1. Vector, this one is a vector 1, right? 10 by 1. Okay? So you're joining the horizontal direction. So this one goes here, right? So we will have 6, 10. Okay? It's too large. This one is here. Okay. There's a H. And what about the I? I is the, okay, I is the 10 by 5. Okay. Vector 2, that is the mat 3. Vector 2 is the 1 by 5. We are joining here. It's a vertical direction, right? And you will get 11 by 5, right? Okay. Does it make sense of this concatenation? Okay, great. Okay, let's move this screen here. And math 3 and vector 2. Okay. All right. And let's move on to the J. So mat J is 20 by the 5 by joining mat 1 and mat 3. So mat 1 is the 10 by 5. Mat 3 is the 10 by 5. What is the joining direction? It's a column direction. It's a vertical direction. So mat J should be mat 1 column direction, mat 3. By the way, what is the size? You're adding these two matrices on vertical direction, so this should be 20 by 5. All right. The last question is mat K is the 2 by 5. By joining the first and then fifth row of the mat 1 in a column direction. Okay. This one is simply we can write a script like mat 1, like the first row, and fifth row, right? In the column direction, right? Like this. Okay. But we can simply write a text script like mat 1, 1, 5, and like this. Okay. Similar to the question G. Okay. Makes sense? Yeah. Let's copy this code and then copy. Oh, except for the here, assign the value. By the way, you should not copy this one and then paste to the bottom of the here, because in that case you regenerate the random number, so U and I is referring the different this given number, meaning that you cannot correct the answer. So we move to the first is run this code to see if there's no error. Oh, there's an error. Okay, let's go to the line 13 here. What's the error? There's no, this one is a val or va1, so we can use this one, right? Okay. We fix the error and run it. Oh, there's one more error. Line 50 here. What is the error? Okay, so mat 1 is the here. Okay. Oh, here. This is not a mat. It's a mat 1, right? There's no matrix. Okay. K is D. K is D versus K. K is D. Mat 1, right? There's no mat. Run it. Yeah. We pass we run without the error. So we can copy this code. Then paste it in here. Okay. Can run this script again. It's exactly same with the run in here. Then submit. Oh, okay. Let's take a look at what is the error. Error is the mat F and mat G. Okay. Alright. Fix this solution. Okay. Oh. A, B, C, D, E. Oh, I didn't solve the F problem, right? F. Okay. Mat F is equal to first mat 2, first column, second column, second column. 2 is what's the third column, right? And then joining the horizontal direction. Okay. Again, similar to the G, we can write a code like this. Okay. Okay, we copy this. Oh, sorry. Copy this. Okay. Can write a script like 1, 2, 3. Okay. Makes sense. Let's test this one. The F. But what was wrong? Okay, I don't remember what I did. So let's go back to the previous. Okay. I don't know what was wrong. Okay. Mat G correct? No. Let's take a look at the Y. Mat G is the first, second, and fifth column, right? This one is the fifth, not the third, right? Okay. Makes sense? The G is the first, second, and third. The F is the first and second and third. The G is the first, second, and fifth. Run it. No error. Okay, let's delete the CLC. So clean out the command window. Remove all the variable in the workspace. Then run it. No error. So we can copy this code. And then paste here. Just to simply run script, no error. Please submit this script and you will get 100% is a pass. Okay? Makes sense? This is a very simple example, but very basic, but very important. Because you first know how to manipulating the vector and matrix. Okay, good. And then let's move on to the next topic, the basic array manipulation. But this problem is basically the same with the first one, so I skip this problem. Okay. Let's solve the character type casting later. Let's first solve the pressure calculation. Okay. This problem looks like engineering problem. Okay. Okay. Let's first save mode 2 tutorial pressure car. We are going to solve the around the 4 different pressure calculation later. Okay, I'm trying to adding the more component on this problem later. Okay, even in the homework assignment, this module. Okay, let's take a look at the problem. Pressure 1, pressure 2, pressure 3 contain the pressure data collected from the station 1, 2, 3 at 1 hour interval starting from the 6 a.m. to the 11 p.m. Meaning that there are 18 measurements and each location, each station. So that's why I generate the pressure one data is like this. This one is the, okay, I'll copy this. Okay. Let's copy this one. Okay. This one is the generate a 18 by 1 vector, right? Okay, it's the same thing for pressure in 2 and 3. Each element is indicating the pressure data at the corresponding this time, right? 6 a.m. to the 11 p.m. Okay. All right, so let's solve the problem A. Create the matrix, the data press, matrix data press. Concatenate the pressure 1, 2, 3 data in the row direction, horizontal direction. So we know how to do that. Pressure 2, pressure 3 in a row direction. It's good? Okay. By the way, what is the dimension? Pressure 1 is the 18 by 1. So if you're joining this three vector, so you will see 18 by 3, right? Okay, so what about the B? B, so create a 1 by 3 vector called the data press 9 a.m. Okay. Contain the data collected at the 9 a.m. from the all station. Okay. So let's take a look at this one. So when you solve this data, is it data pressure? Okay, pressure calculation problem. I recommend that you draw this figure. So like here, right? This one, no, is it 2? Okay. So data looks like this one, right? And let's draw the guideline. This one is 18 data. I mean, it's like this one. Here's 6 a.m. data. Here's 7 a.m. data, right? So it goes to last row is the, what's this? 11 p.m., right? So first column is the pressure 1. There's a 3. Press 2, press 3, right? Okay. So question B is asking the 1 by 3 vector called the data press 9 a.m. contain the data collected 9 a.m. from all station 9 a.m. data. It's referring to this row vector. Okay. This one is the first row, second row, 8 a.m. is the third row, 9 a.m. is the fourth row, right? Okay, that's why data press, fourth row. Okay, makes sense? Okay, it's all station, because we are dealing with the 3 station, right? C is a create a matrix, the data press new. So copied from the data press. Okay. And you realize that data from the station 2 was abnormally low and should be corrected by adding the 10. Okay. Please correct the corresponding value in the data press new. All right. Okay. One way is to solve this one is we are making just a new vector from the scratch. So data press, for instance, data press new is a press 2, sorry, press 2 new is the plus 10, right? And then data press new, let's comment it out, this one is the data press 1 press 2 new press 3. Okay. This is the one way, but this is not a way that I recommend in this problem, right? So we are commented out. So copy it from, we can correct only the second columns like this. We are going to change the value of the second column, right? That is the station 2 data. We are pointing out is the second column, and then read the value, right? Plus 10. Okay. This one is a kind of execute the script like you're reading the value second column and then plus 10, and then assigning those value in the second column. Okay, that's this operation, right? Correct the corresponding value. Okay. Okay, let's say we are computing the force, okay, by multiplying the cross-sectional area. Okay, so let's go to the here. Okay, so not this value is not see in this line, so I copied this one. The area divides a constant is a constant area. Okay, area device is the 3 by 1 is a column vector because we assume that there's a different cross-sectional area on the pipe in each station. Okay, but let's solve the D first. Okay, if the cross-sectional area of the devices at all stations are constant and given as area device constant, this one. Okay, please convert the pressure data in the data press new, because we are using this one because we cracked the value into the force, assigned to the data force 1. Okay, data force 1 is the, can we do that? Data press new multiply area device. Okay, how does work? Okay, this one is a matrix, it's a multiplication, but it's a multiplication between the matrix or vector and the scalar. That's why this one is the scalar operation. So the scalar multiplication of each of the element. So basically this is what we are doing right now, right? There's the pressure data. We are multiplying this area of each pressure data to obtain this force data. Okay, this like this. What about the E? Is the cross-sectional area device at stations are different, and there are areas given the area devices. Okay. So please convert the pressure data to the force data. Assign the data force 2. Okay. Because the area, cross-sectional areas are different. We need to multiply the corresponding cross-sectional area of each of the pressure data. So we will make like this. Maybe the force. Force 1 is pressure 1 multiply, oh, not this one. So let's read the the pressure data inside of the data pressure nu. Okay, first one is the data pressure nu. First station data multiply area devices first, right? First value is the cross-sectional area of the device at the station 1. Okay, can copy this. First 2, first 3, second column and third column, and second value and third value. Okay, then data force 2 become a, can concatenate this force data in the row direction. Okay, but you can also write a code like this. Data, what is the size of the data first 2? Data first 2 is the, you can initialize this matrix 18 and 3, right? And then you're directly assigned this force data to the first data first 2 matrix. For instance, here you can write a code like this. First column and second column and third column. Okay. Either way is fine. But for me, I prefer this code. Because it'll be better, assign this size of the matrix in advance, and it's kind of the more organized, right? Rather than the joining the this variable later. And also in this case, we are creating the the 4 variable, but in this case, we only create one variable, right? All right, and the last question is, you still don't trust the data from the station 2. So please create the matrix 18 by 3 matrix named the data press good. Copy from the data press good. Copy from the data press. Okay. And then remove all data from the station 2 in the data press 2. Okay. Basically, you're going to, remove all the station 2 data. You can simply first pointing the second station data. How to delete that? You can simply put the empty vector. Okay. All right. So let's run this script. Okay. There's an error where if you go to, you can simply click this one. Oh, data press, right? Okay. Fix that. Run it. No errors. I do it again. Run it. No error. Okay. Let's copy this code. Remember, you should not copy this, the given code and paste it here. Okay. You should read the value of this variable. You should not create the new same variable in this line. So here, copy and paste here, run it, no error, submit. Yes, okay. All tests passed. Okay, good. All right, and then let's move to the replicating built-in function, fliplr, flipud. Okay, go to this problem. Okay. Before starting this problem, so it is important to understand exactly what is a flipud function too. LR is a stand for the left and right. UD is a stand for the up and down. It's kind of the flipping up and down, flipping left and right. Okay. If you click this link, you will see how to use the flipud. Okay. Flipud is a return to A. It's a row flipped in a up and down. It's a flipped row. That is a UD. Okay. So for instance here, A, if you apply the flipud, you will have a 10 to 1. Okay. Flip arrow is perform the same operation in left and right. So if you see here, A vector, A is a row vector. If you apply the flip arrow, it's a flip in the row direction. It's a horizontal direction. Okay. Okay, the question is, given an n by n matrix named n mat, replicate the flip arrow function without actually using it. Okay. Here, mention that the problem say you must not use the flip arrow function. Okay. If you use the flip arrow function in here, you cannot pass the test. Okay. Because I made this test. Please do not use the following function. Okay. So MATLAB grader is automatically check that you used these functions or not. Okay. Good. Let's store this file mod to replicating built-in function flip arrow flip. Okay. So here are the given code. Okay. How to replicate a functionality of the flip arrow. Okay. And mat. First, copy the n mat to the here. Use the flip arrow is copied from as unknown variable for this question. So flip arrow mat. Okay. And mat. Okay. How to flip this one is a left and left to the right. Okay. That is swapping, right? Swapping the column. So basically flip swapping column. You do that. Let's go to the class material. So here's the thing. The swapping the third and the second column, you should do here, you place in the value in the reverse order, and then assign this one is like a forward order. Okay. You understand this is a slide, right? So we can do the flip there, all the column in the same way, right? So flip lr mat something flip r something. Okay, how to filling in this space. This is the we are filling the column, right? Okay. Because in this case, n is a random variable. We don't know the size of the n. Okay, so let's say n is a 3. Okay, let's give a simple example. Okay. Okay. When the n is a 3, okay, let's say n is a 4. This one is n1, mat1. How to write this code here? Mat1, all the column. So we can place, we are pointing this column in the reverse order. So 4, 3, 2, 1, right? Equal to mat1, mat1 is the fourth order. Okay. Then the first column goes to fourth column, second column goes to third column, third column goes to second column, fourth column goes to first column. That's the flipping, right? Left and right. Okay. But in this case, we don't know the size of the matrix. We only know the size of the matrix is as an n, right? So how to write this script? You see this? This one is kind of continuously decrease. It's a continuous increase. What operator? So what syntax do we use? It's a colon operator, right? So first, I'll show the slide. This is a syntax. Then you're going to generate the value from the 1, 2, and here, because these are the n dimension, right? Okay, so here, so you can write a n. Again, here, this one give you this row vector, right? So this the output of this colon operator is become a row vector. So we should put the row vector here, right? So this one is a 1 n. Sorry, this should be n minus 1 and 1, right? Like this. Here, 1, 2, and does it make sense? Okay. You can also write a code like this. Okay. I mean, this is kind of a commutative. It's like you're pointing the first, second, third, and fourth, but you assigning the value from the reverse order. Is the first column to the 1, in this case, right? In the first column, value assigned to the last column. Okay? Make sense? Okay, good. All right, the B is flip up and down. Swapping. What is this one? Swapping row, right? I think the way flip up and down is the exactly same. How can we write this? Flip the mat. Okay, this one is basically, you know, flipping the row. So you write this index in the row direction. Access all the column, all the value in the horizontal direction, and you're writing this one to the head. Okay, does it make sense? Okay, so if you're confused, so you're looking at this slide, this one. Okay, let's do this. Let's run this script. No error. But let's take a look at this flip mat. So flip mat is actually, you know, flipping the column in the left and right. Okay, how can we see that? One way is let's clear all the variable and then run it. And if you see that, you can click this and you will see this table is a value assigned to this matrix. Okay, and you can click this one. Okay, then you can pick this tab. So like move to this window to here, then compare this value. Okay, for instance here. Okay, so let's 15 column, and no, first column is goes to last column, right? Second column goes to here, right? It works, right? Okay, you can check the, you know, the outcome of your operation using this workspace. That's why I highly recommend using this workspace to check your answer. Okay, good. By the way, here, so what if I, you know, give you like this, okay? Meaning that, so the code is to generate a very large dimension, okay? Very large dimension. So if you run this, it's not easy to check that your answer is correct or not. So this is too many columns. How can we do that? We can just, now these are the original code, but for testing purposes, you can just simply assign the just n value, just for testing. Okay, so in this case, if you run it, and this size is small, so you can easily, you know, check your output because the, you know, size is small. So you can easily compare. This one goes to, oh, sorry, oh, by the way, here, so every time you clear this up, okay, so run it, sorry, all, and flip, and that. Okay. So this one goes here, this one goes here. Okay, makes sense? Okay, so let's copy this code and then paste it here. Then run script. no error. Submit. Yes, right? I passed my script is passed all tests. Okay, good. Okay, so let's move on to the next problem. Next problem is a simple linear indexing. Okay, so close except this one, and then save the tutorial simple linear indexing. Okay, and then let's read the problem description. So you generate the matrix, a 5 by 6 matrix. Here's, okay, just copy this one here. Let's solve the one by one. Variable value 1 is the, which is element to locate in the third row, math 1, third row, and then fifth column. Okay, that's easy, right? And value 2 is the last element. Last element in terms of the linear indexing. Okay, if you put a single value here, what is the last element? The 30. Or, sorry, if we don't know the size of the matrix 1, we can write like this, right? And where do we find this one? In here. Here, okay? To refer the last row or the column, use the n. You can use the n for the linear indexing. If you're using the subscript indexing, so you can write like this. All these three are identical. Okay, let's do this. Okay. What about the C? Vector 1, which is a row vector containing all elements from the second to the 17th element of the matrix 1. Okay, that's the linear indexing. So can simply second to 17, right? This is a way how to use the linear indexing. Okay. What about the D? Vector 2, which is the 1 by 30 row vector containing integer number from the 1 to 30. So this one is a 1 to 30, right? This one is a colon symbol, right? So this one is basically in the same way, the first element, the step, and the last element, right? Okay. So what about the E? Mat E is the, which is the 5 by 6 matrix reshape from the vector 2 in order. So we'll learn about the reshape, right? Okay, so if you go to the last slide, reshape is the A is your vector or the matrix, and then size, assign the size of the B, your output matrix, right? So in this case, output matrix is the size is the 5 by 6, right? And your vector is your input vector is a vector 2, right? Okay. So how does a 1 to 30 is placed in the 5 by 6 matrix? You know, it's the order of the linear indexing. So for instance, no, this row vector, vector 2 is the 1, 2, 30, right? So mat E is the 5 by 6, right? So you can place 1, 2, 3, 4, 5, 6, 7, 8. That's the linear indexing order, right? Okay. Like this. Okay. You can see this slide, the linear indexing. See this? 1, 2, 3, 4, 5, 6. Okay. Here the value is placing in this order. Okay. What about the F? Mat F is the reverse order of the M1. Okay. How can we do this? That is a reverse order. This is different from the flipping arrow, flipping up and down. So basically, this one is the value is placed in the reverse order. The way we are making the mat F is we first generate the reverse order the vector, and then make a 5 by 6 matrix. So you can see like a vector 32 minus 1, 2, 1, in reverse order vector, reshape, using the vector as an input vector, 5, 6, like this. Okay. Or you can write a script like this is one way, the other way is mat F reshape vector. We are reading the value in a reverse order. Okay, so 32 minus 1, 2, 1, right? Okay, 5, 6. This is a one way. The other way is you can put the and. In this case, a vector, this should be vector 2. Okay, if you are trying to use this existing vector 2, like this. Okay, does it make sense? Okay, or if we know the built-in function flip, it's LR, right? Vector 2. Okay. Here I'm going to explain how to see if these individual values are producing the same value. For instance, here, first we run this script, no error, right? Mat F is assigned to this vector, right? This is a matrix. We copy this and then paste here. Oh, sorry. Here. See this? These two matrices are same, meaning that you can write a script like this, or you can copy this one, then paste here. See this is all identical, or you can copy this. All these matrices are identical, okay? Meaning that you can write a code either this way, or this way, okay? Alright, so then you can copy this code and then paste it here, okay? Then run script, no error, and submit. Oh, okay. There is a problem of the value 1, the value 2, and then mat F. Okay, let's take a look at the one by one. Okay, let's take a look at the what is wrong. Okay, here value 1 is the element located in the third row and fifth column. Okay. The submission must contain the variable name is a value 1. Okay. Oh. Is it not a value 1? Because L and 1 is look same, right? Oh, I put the 2 1 here, right? So this should be val L, right? I guess this one val 2 should be the L. This one is L. Okay. All right. Okay. So I guess I fixed this error. So I think the test design is wrong. Yeah. So this should be value 2. So basically I'm checking the the value 1 in the both test. So I'll fix that. But anyway, I fixed the value 1 here. Let's take a look at the math. Another incorrect answer is the math F. Okay. What is the wrong? So reverse order of the math 1. Suppose that math 1 is then math 2 become like this. Okay. So in this case, we generate the vector in the reverse order and then reshape the 5 by 6. I think it's correct. Okay. Oh, this one is the reverse order of the mat 1. The reverse order of the mat E, right? Okay, so this is not correct. Okay, because we need to make the reverse order of the mat 1. So this is wrong. And where is the mat 1 here? The mat 1 is already defined over there. So here's the thing. Mat 1. Okay, so let's how to make the reverse, order of the mat 1. We first flatten this number. Okay? So meaning that we are using the linear indexing and then flattening this mat 1. Okay? So let's take a look at let's print out this value. For instance, here's how we check the value during the check the value in the line by line. So this is called the debugging. So here you can put the break mark here, and if you run this code, the code is a stop here. Okay, meaning that the code is running up to this line. This script haven't executed yet. Okay, so clear. Then let's print out what the inside of the mat 1. Mat 1 is this one. So what is the vec? Okay, see this? Okay. So once we flatten this one, is using the linear indexing and then make the reverse order. Why? So you're accessing this element of the matrix 1 in the reverse order. That's why the inside of the vec variable, the element is applied as a reverse order. Okay. Then we can just simply reshape the function is 5 by 6. Then this is the way of placing the element of the element in the mat 1 in the reverse order. Okay, you can run it. Okay, then it's the mat F. So this is the mat 1. This is the mat F. the number is placed in the reverse order. So that's the answer. Okay. Let's delete this one. Okay. So, okay, let's move on to the array manipulation. Array manipulation, we can make the new script and save the module tutorial array manipulation. Okay, let's read the problem description. You need to write a script that creates a variable named. We know this types of the format, right? Okay, so first we copy this. This one is to generate the 1/30 a row vector, right? Okay. A is contain the 1/3 row vector. Each element are 1 through 30. Vector 1. So 1 through 30, right? This is straightforward. Vector 2 is to contain the vector 1 in the reverse order. We learned that how to select the reverse order. So like a vector 1 and -1 and 1, right? Because this one is like a indexing, right? We place the indexing to access the vector 1 to read the value in the reverse order. Okay? Make sense? Okay, good. What about the C? Vector 3 that contain a vector temp in a reverse order. For instance, vector temp is a 4, 3, 2, 1, 5. Vector 3 becomes 5, 1, 2, 3, 4. This problem is basically ask you, okay, I'll give you the vector temp, that is the index vector. Okay? So you can access the vector in the vector 3 is basically vector 3 is contain a vector in the vec temp in a reverse order. So how can you make the reverse order of the vec temp? This is similar to the question B, like and -1 and 1, right? Okay. All right. What about the D? D is a matrix 1 that contains the 3 by 30 array joining the vector 1, vector 2, vector 3 in the column direction. That's easy, right? Vector 1 column direction is a vertical direction, right? I mean, so this is not a, yeah, this is a column direction, right? Yeah, like this, right? It's a vertical concatenation. Okay, makes sense. What about the E? Okay, matrix 2 is a copy from the matrix 1. And then swap the element the first and second row in the matrix 2, and then swap the element in the second and the third columns of the matrix 2. Okay, let's do the one by one. Matrix 2, how to swap the first and then second row. Okay, you're pointing out the second and then second row and the first row, then you're assigning first and then second row. Okay, so this first row goes to second row goes to first row. Okay, That is a swapping, right? And then swap the element in the second and the third columns of the matrix too. This is the line 17 is the row operation. This one is a column, right? Second and third, so we're pointing third and second. It's a matrix. Second and third. Okay. Does it make sense? Let's run this script. Okay. Adder. Where is adder? Oh, here. Okay. That matrix 2, right? Okay. Let's run this script. No adder. Clear. Let's run it again. No adder. So you can copy this script. Then paste here. Run script. No adder. And submit. Good. Can pass the all test. Okay. Good. Okay, so here save module tutorial 3D matrix. Okay. So MATLAB used a multiple function and operation that allows you to create and modify matrices in the third dimension. The third dimension is the depth dimension. So remind your memory, here's the 3D matrix. This is the column direction. This is a row. No. This is a row, column, and depths. Okay. Okay, good. Let's solve the one by one. Construct a 3 by 3 matrix filled with n. Okay. Copy this code. Okay. Use the nmat. Okay, construct a 3 by 3. Okay, 3 by 3 matrix, and then fill with n. So how can I fill with n? You can there are lots of ways to do that. So we are trying to access all the row, all the column, and then assigning the n. So we can, we don't need to match the the size and left and right hand side if you're assigning the scholar, right? Where is it? Here. This one, right? You don't need to match the left and right hand side if you assigning the the scholar, or you can write a code like this. What is this one? This one is subscript indexing. What is this one? Linear indexing. Okay, you can assigning the value using the linear indexing. Okay, or you can define you can initialize with the 3 by 3 vector having n, like this. Okay, or what is this one? Matrix and then scholar operation, that is this one, scholar operation. 0 plus 5 is so you can 5 plus operation is conducted in the each element on the matrix on the vector. Okay, so let's do this. Oh no, not 5, sorry, this one is n. Okay, so for instance n is I'll say 5. Okay, Okay, so you can copy this and then run and math. So 5 by 5. Okay, or you can copy this code and math. So 5 by 5. Okay, so clear and n is so 5. Okay, and then run this script. Let's run this one. Okay. This one is also 5 by 5. What about this one? This one is also 5 by 5. Okay, there are many ways to generate the 3 by 3 matrix having all the 5 value. Okay, okay, good. Let's move on to the next problem. Okay, okay. B is the math 3D is a copy from the end math. Okay. Then append the math 1 at the second location. Okay. Okay, here. Here. Okay. A vector can be extended by the referring to the element and assigning the value. Okay. And the vector cannot refer the index that where the value does not exist. Okay. So in this case, once you make the vector 3D with this 2D matrix, and how to append the M1 at the second location in the third dimension, meaning that it's the second layer, okay, in the depth dimension. Okay, that is, you can just pointing out the second dimension. It's a second location at the depth dimension, and you can assign the 1. Okay. If you're not easy to understand this one, you can simply make the initial 3D matrix with a 3 by 3 second, right? And then math 3D. The first layer you're assigning the end math, and math 3D the second layer you're assigning the math 1. Okay, they both are same. Okay. Let's test this one. Okay, C is the math 3D2 is a copied from the math 3D. Okay, replace the element located at the first row of the array at the second location in the depth dimension. This one is telling you the second layer. How to replace the element location located at the first row. How to access this first row. So first row, second layer, right? Okay. How to assign all the value with the n? You can just simply this one. Okay, that is this one, right? When you assigning the single scalar, we don't need to match the dimension. Yeah, that's it. Okay. What about the D? D is D math 3D2 and math 2 in the depth direction. It's like a concatenated. So concatenating is just the appending, right? So the easiest way to do this is the 3D. So you first assign the 3D2 and then what is the dimension? Third dimension. Okay, and math 2. Okay. So sometimes we don't know what the size of the matrix. But in this case, we can write a code like this. Plus. Okay. This one is simply adding the mat2 at the end of the matrix 3D2. Okay. Is it clear? But you know, similarly, you know, if you know the size of this array, this is not a bad idea. You can initialize the 3 by 3, 3, and then mat 3D3. You're accessing first and the second layer, assigning the mat 3D2, right? Mat 3D3. Last layer is a mat 2. Okay. Okay, does it make sense? This one, okay. I'll write the, you know, option 1. Okay. Option 2. Okay. This is the option 3. Well, for me, I prefer this way, but you know, but it depends on the problem that you're solving. Okay. Let's leave it this code here. Okay. What about the E? Okay. Mat 3D4. Mat D4 is copied from mat 3D3. Okay. And then replace the third location in the depths. That is third location, right? It's like a third location depth direction is a third layer. So replace with the identity matrix. How to generate the identity matrix, a 3 by 3 identity matrix. That is here, right? Oh, sorry. Here. Okay. I 3. Okay. Makes sense? So, but when you run this, you can just push the run and check the, you know, validity of your code. Or you can just bring the stopping mark here and then run. And then you can see if your nmat is correct or not. You can just print out like in the command window, or you can just click the variable like this. Okay. And then if you want to check the answer of the B, you can put the stopping mark here. And then, so this is a stopping mark or the breakpoint. I mean, the breakpoint is a better word. So you can continue. Okay. And you will see the, so let's print out the mat 3D. How does it look like? See this? This is the first layer, and then this is the second layer, right? So the first layer is the year and mat. Second layer is the mat1, randomly generate in the beginning. Okay. And then what about this one? Okay, putting in. You cannot make the breakpoint under your comment because you know all the comments are ignored when the malware executes your script. Okay, so if you run this, what are the inside of this one? Okay, the same, but you know, the first columns of the first row of the array in the second location replaced with this n number. And, okay, and it's 961, right? Okay. What about the D? Okay, run this. Right inside of the mat 3D3 is a 3-layer. The third layer is the matrix at the third, third location in the third layer is the mat2. Okay. What is the mat2? Mat2 is the same as this one, right? Okay, and last one is run this. Can print out this one. See this? Last layer, there's the identity matrix. Okay. So in this case, if you run it again, your code is stop here, again. So if you want to run all the code at once, you can just turn off each breakpoint, run it. That's it. Okay. Okay, let's copy this code and paste here. Run it. No error. Submit. Okay. I passed all tests. Okay. Good. Okay, last problem is a character type casting, the 3-star problem. It's relatively, challenging. Okay. Okay. Before solving this problem, please review these 2 slides. Where is it? Character and character vector, and then character typecasting. Okay. Okay, this is kind of the challenging problem. So, okay, store this value mod tutorial character type casting. Okay, and then we've only this file. Okay. So ASCII table when you're solving this problem, solving this question. Let's click this. So remember that all the characters can be mapped to the equivalent numeric value. So in this in our lecture, so 97. So A is mapped to the 97. I'll say all the character is mapped to this numeric value. These are the so we can do informations are tableized in here. That is the ASCII table. So if you go to the this one is a decimal. If you go to the 97 here, that is A, right? 98 is a B, okay? And 65 is a capital A. Okay. You don't have to memorize this one, but I'm just showing that, okay, this character is a map to this value, and this value is a map to this character, vice versa. Okay. Okay. Okay, the following variables are created advanced using the rand-i and will be used for solving question. Okay, so you first understand what it is. What is this one? Okay, let's take a look at the one by one. Rand-i from the 65 to the 122. Okay, so this one is generate the value from the one single value from the 65 to the 122. Okay. So what is it? And then convert the character. So from value to the character. So let's take a look at what is this value. 65 is the capital A. 122 is the Z. So basically character len is generate the character vector from the capital A to the lowercase z. Okay, there's a lowercase number, lowercase character here, capital character is here, or this one is just a symbol. So basically, this line, this script is that this one is to generate the one single character among the this one, this character. Okay, you first clearly understand what it is. Okay, let's solve the problem. Okay, vector A which contain the lower cases a letter from the A to Z. Okay, I guess it's like a lowercase, it's a character vector, so I mean this should be character, not char vector. It's a character vector. I mean the answer is like a B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, right? You can do like this, but is there any easy way to do this? I mean, actually this is an answer, right? Character contain the lowercase letter from the A to Z. Better way that I want to encourage the students to write a code is like this. What is the A? So these are the kind of the continuously increased, the map to numeric values continuously increase. So you can write a script like, what is A? A is the 97, 97 to 122, like this. Can you understand this one? You understand this one, right? Maybe. What about this one? A, right? So character A is a map to the 97. 97 is a map to the A. So conversion of the numeric 97 to the character is this A, right? But this vector, this one is a vector, row vector generation. 97 to 122, right? So if you convert this all value, this all the row vector, that become this character. So let's print this out. See this? They are same, right? So basically this question is, you know, allowing students to write this code. Okay, if you know this one, how to, you know, the B is how to use to make the character, you know, lowercase alphabet letter from the Z to A. That's very easy, right? You can just simply like this, right? Okay, so you copy this, C to A. Okay, you know, this objective of this problem is a character type casting. So basically, I'm telling you how to manipulate the character and character vector. Okay, we're going to solve the many problems or involving this character. Okay. All right. What about the C? C is also easy, right? So where's the starting numbers of the capital A? Capital A is 65, right? 65 to 90, right? 65 to 90. Okay, let's print this out. Okay, good. All right. What about the D? A character vector, vector 4, which is the copied from the vector 1. And then 10th element is the letter of the J of the vector 4 is removed. How to remove the character? By the way, how to remove the value? So you need to use the empty vector. So in this lecture, I highlight that the way of the manipulating the character vector is exactly same with the way of the manipulating numeric vector. So in this case, you can simply vector 4. Where's the location? The 10th location is like this. Okay. Let's copy this. Run. Oh, sorry. There's no vector 1. Oh, okay. But in this case, if I copy only this code and then paste it here, there's error because there's no undefined variable vector 1. Because, it works if I run everything. Because in this case, a vector 1 is created in the line 5. But if you only copy this one, it didn't work, right? Because we didn't define the vector 1. Okay, so we can just simply. That's why sometimes this one is useful. Okay, run, but run it. Vector 4 is the hi, no j, right, and k. Okay. What about E? E is a little bit different problem. E is offer. We need to use the logical operator to test if a character ran is the uppercase letter. Okay. How do we identify the character ran is uppercase letter or not? Okay. Again, all letter can be converted to the numeric value. Okay, so if we convert the character ran into the numeric value, if this value is the uppercase letter, this numeric value should be placed from 65 to the 90. That is the range of the capital letter. Okay, so to do this, I would like numeric character ran so double character ran. Okay, then you're going to vary it to see if character ran is inside in between the 65 to the 90. So we'll learn about that one, right? Character ran is more than 65. What is the 65? 65 is the numeric value of the capital A, and numeric ran less than 90. And sorry, this should be equal. 90 is a capital Z, right? 65 is a capital A. Okay. Let's try out this one. Okay. For instance, here, what are the num character ran now? 68. That is capital D. So if you run this, 1 is that true, right? Does it make sense? This one is a little bit tricky. That's why there are 3 star problem. But to do that, you need to first understand how the character is mapped to the numeric value is mapped to the character vector, and also you need to know how to use how to use a relational operator and the logical operator. Okay, I repeat the syntax several times in the module 1, right? What about the F? So we can still use this one, and is a letter. What we are asking this, see this? The character is generated from the 65, capital A, to the Z, right? But there's a non-character value here. Okay. So how to write the script? You just check that your character is placed outside of the inside of the capital letter range and inside of the lowercase letter range. Okay, so you can, like a condition 1 is your letter is inside of the, I mean, we can redefine, we can rewrite this one, or we can use this variable. But I'd rather, to rewrite this maybe this recreate this overriding this value, or we can change it, maybe different name. Let's shorten. Okay, F. Okay. Okay. Check if your terrain is capital letter. Okay. To check the character ran is an English letter, we need to have another condition then. What is the value of the lowercase a? That is 97. What is the lowercase z? That is a 122, right? So you can write a script like and character f less than 2. Okay. Check f. Okay. To check to see if is a letter. So what kind of the logical operator do we use? Or, right? Or, it's not the n, right? The character, can be the both, capital and lowercase, right? If number is the character ran is the alphabet, is an English letter that satisfy either condition 1 or condition 2. That's why we are using the or operator. Okay. I guess this is a very good, very good question. Okay, I'm pretty sure that similar problem is in the, the quiz, I guess. Okay, good. Okay, let's run this script no error, right? Okay. By the way, we can write this final question using the different script. I'll introduce some kind of another optional script. Okay, so this one, option 1, option 2, I'll say. How about this one? Okay. But this script is starting from, we are generating the character ran from the 65 to 122. So we know that character, so non-alphabet character is a place in the range between the 91 to the 96. This one is just checking that character ran is a place on that range. So if you yes, that is a non-alphabet character, right? For instance, if you let's say putting in the non-alphabet character, what is the value of this one? That's true. But this one is asking is the character ran is an English letter or not. So that's why we put the na. Or can put this one. Okay, does it make sense? Okay, the biggest difference between this one is that this one is actually checking the character ran is the place in the alphabet. So lowercase and a capital case letter, English letter. But this one is just checking that character ran is a place on the non-alphabet character in the range of that we generate the character ran. Okay. I mean, personally, this solution is better, but this one is also the very good, the exercise to learn how to use this not operator here. Okay. Let's copy this one and check the answer. Check the test. Okay. I guess I can pass the tests. Okay, wonderful. Okay, so we solved the 7th problem. I know this one is it's kind of the lecture, and all this tutorial is kind of the long because there are many contents in the module 2. But later, so our lecture is getting shorter. But module 2 is very important to use the MATLAB to learn the programming. This one is pretty much basic, but it's very important. Okay, see you in lecture of the module 3 later. Bye.